Okay, so last day we looked at the octet rule. We looked at Lewis dot diagrams or electron dot diagrams, and we'll kind of continue with that today, looking at the octet rule with ions. For any of you, this is only Monday afternoon, but if you've done your labs already, had two groups do their labs yesterday and another group do their lab today, you've kind of already looked at this in that lab, meaning looking at the charges of ions. So I mentioned the other day, excuse me, about the octet rule. The octet rule is a rule that says atoms or elements will become stable when they get 8 valence electrons or their valence energy level is full. So the other day we looked at sodium, sodium Na. The electron configuration for that is 1s2, 2s2, 2p6, 1s1, I do believe, yep. Or sorry, 3s1. And this electron will leave to give it a full valence shell in the second energy level. Now, when that electron leaves, that means that sodium will become +1. And this is true for everything in group 1. In group 1, we have lithium, sodium, potassium, rubidium, all of these elements, cesium, they're all +1. So everything in group 1 is +1 because they have one valence electron in that energy level to give away or to get rid of. So let's look at another one. Let's look at oxygen. Now, oxygen, this on your periodic table is in group 16, or what we would call 6A. This means it has 6 electrons. So 1, 2, 3, 4, 5, 6. Now you'll notice 2 of these electrons are not full. They're not lone pairs. So the question is, would oxygen, would it rather lose 6 electrons or gain 2 electrons? And the answer is gain 2. It's a lot easier for this element to gain 2 electrons. And that means oxygen is typically 2-. And that is the same for anything in group 16. So oxygen is 2-, sulfur is 2-. There's other elements there that we won't really get into, like selenium and tellurium. That's not really for this course. So group 16, these are all 2- because they would rather gain 2 electrons. Now hydrogen, is a little special. Hydrogen, because it only has 1 electron, it can do 2 things. It can give away an electron or gain an electron. The form that we will be using most in CH1120 is H+, but it can also become H-. And that's one of the reasons why hydrogen is listed in group 1A, but it's also a nonmetal. It kind of explains why hydrogen is in a weird place on the periodic table. It's in group 1A because it forms a +1 ion, but it's also a nonmetal we need to remember, and it can also form H- or H1-. All right, so I would love for you guys to try this one. Let me just do something for 1 second. These are metals, and these are non-metals. Metals are positive, non-metals are negative. So let me look at let me look at aluminum. Aluminum is in group, sorry about my pen there, 13 or 3A. This means aluminum looks like this. And the question is, what type of ion will each atom form? Will it form a cation or an anion? Well, aluminum is a metal. Metals always form cations. So this will lose 3 electrons and become Al3 positive. The charge on this, because it loses all 3 of the electrons, is 3 plus. Metals will always lose their electrons. Non-metals will always gain their electrons. So this is in group 2. This is in group 15, group 17, group 18. All right, so I'm going to pause myself and I'll give you guys a couple of minutes, maybe 2 minutes, to try A, C, D, and E. So I'll be back in a few minutes. Good luck. And if you have any questions, let me know in the chat. All right, so magnesium is a metal. It's going to become positive. Anything in group 1 and 2, for example, are definitely positive. So magnesium, let's maybe pick a different color here. Magnesium would look like this. It has 2 valence electrons. So what it would usually do is lose 2 electrons and we would get Mg2 plus. Now, if you guys wrote Mg positive 2, you're not wrong. It's just typically in chemistry, we write the number first. So 2 positive. And this means that there's two more protons than electrons.
Because magnesium in group 2?
Sorry, can you repeat that?
Magnesium lose 2 because it's in on group 2. That's why it lose 2.
Yep, exactly. So the question was, does magnesium lose 2 because it's in group 2? Yes. Magnesium in group 2 has...
So group 5 lose 5, group 7 lose 7.
Okay, it gets a little bit more complicated than that because, okay, again, we're trying to fill the octet. So metals lose and non-metals gain. So it does get a little bit more complicated than just like if it's in group 7 or 17, it loses 7. No, metals will gain electrons. So metals in group 1 will gain 1 electron. Metals in group 2 will gain 2 electrons. Sorry, I'm saying this backwards. My apologies. Metals in group 1 will lose 1 electron. Metals in group 2 will lose 2 electrons. Metals in group 3 will lose 3 electrons. Well, non-metals in group 15 will gain 5 electrons, or 3 electrons. So let me just explain why. Phosphorus in group 15 has 5 valence electrons. So 1, 2, 3, 4, and 5. So if you look at phosphorus, it has 1 lone pair, and then it has 3 single electrons. So it has room to gain 3 electrons, and that's where I get P3 minus. Remember, nonmetals gain electrons. Chlorine, I guess I'll pick another color for that. Chlorine is in group 7, so 1, 2, 3, 4, 5, 6, 7. It only has room to gain 1 electron, so this would be Cl minus 1. And then Ar, it does not form an ion. And the reason it doesn't form an ion is because argon is completely full because it's in group 18, it has 8 electrons, so it cannot take any more. All right, let me look at the chat and see if there's any questions. Okay, so Abdul Halim asks a good question. I had this question from another student, actually Iman, who's in this class as well, asked this on Thursday. What about group 14? Group 14, you will not be asked about. So group 14, right? Do they gain 4 electrons or do they lose 4 electrons? That's a really good question, and not one that you'll be asked in this course. My hydrocarbon students, they deal with group 14 all the time because we're talking about carbon, the element in organic chemistry. Typically, it would be gaining 4 electrons, but don't worry about group 14. Okay, I wouldn't ask you anything so tricky, but that's a really good question to ask. So you guys, in summary, I mean, I didn't do this for the other class, but I can do this for you guys. If you are the type of student that just wants to memorize, group 1 is like x plus 1. Group 2 would be x2 or 2 plus. Oh my gosh. Group 3 would be x3 plus. And then you get into the non-metals. So group 5 would be x3 minus. Or 15, group 16 would be x2 minus. 17 would be x1 minus. And 18, the noble gases, are just x0 or x nothing. If it's not in group 1, 2, 3, 15, 16, 17, or 18, I have to give you more information. All right. Again, Mohammed in the chat says, what about group 4? Don't worry about group 4. It's just, yeah, not for chemistry 1120. Group 4 can be positive 4 or negative 4. Typically it's negative, but I won't get into that in this course. All right, I think we're almost done. I want to read that. Okay, this is good. We had not too much longer. Just a little note here. There are compounds that we're going to look at in section 3.4. That's not the next section, it's the section after. But there are at least 3 chemicals I can think of that don't follow the octet rule, and we will come back into this in section 3.4. All right. So let's get into 3.3. Just give me, 10 minutes or so and we'll be done here. I want to talk about ionic bonding. Now, this section ties really nicely into Lab 5, which you guys have been doing this week. Some of you have already done Lab 5, some of you might not have, but this kind of ties into that. So I won't read all the outcomes. There's a lot of outcomes here. Basically, we're just going to look at ionic compounds. What are they and how do they form? So, definition reminder. Compounds are chemicals made of 2 or more elements. There are, however, different types of compounds. There are ionic, molecular, metallic compounds. The types of elements in a compound really tell us to find the properties of the compound, and they can tell us a lot about what each compound kind of would, what properties they would have. So what I'm trying to say is the property, like if you put non-metals together, they make molecules. These have very different chemical properties than ionic compounds, which are made from non-metals plus metals. So I'm going to give you an example on the next slide. I'm reading the chat from another student, Iman. You mentioned Lab 5 being really complicated. I agree. I think Lab 5 might be one of my favorite labs, but it is definitely a little complicated. You guys have to kind of use what I would call crime scene investigation skills or CSI skills, and you have to study all of these unknown chemicals and then apply it to, or sorry, all of these known chemicals, and then apply it to identify an unknown. It's tricky, it's a little complicated, but it is one of my favorite labs. All right, so hold on 1 second here. Just gonna do something. All right, so there are 3 types of compounds, roughly 3 types. There's some other examples I could give that would fit into these 3 types, but basically we have ionic. Ionic compounds are made of a metal and a nonmetal. So an example of an ionic compound would be like sodium chloride, table salt. We have, and this is what we're going to do in section 3.3. We have covalent compounds. Covalent compounds we'll look at in section 3.4. These we sometimes call molecular compounds or molecules. These are made of only nonmetals. So like this example on the left is obviously H2O. Another example of a covalent compound would be like CO2. These are compounds made of only nonmetals. And then we have metallic compounds. These can be alloys or compounds made of only metals. Now, one thing I need to mention here, really important that you guys know, is if you look at your periodic table, right, and you have your staircase, metals are here, nonmetals are here. We're not worrying about metalloids. We're dealing with metals and nonmetals. All right, I have a question in the chat. CO2 is definitely covalent. If you look at the periodic table, C and O are here and here. So CO2 are non-metals, and we call that covalent. Don't worry about this for right now. We'll talk more about what covalent versus like ionic means in another section. All right, so we're going to look at ionic compounds. I'm going to show you an electron dot diagram, then I'm going to do one, and then I'll leave 2 for you guys to practice. So just a couple more minutes. So ionic compounds are made of a metal and a nonmetal always. No exception, no, chemistry is full of exceptions. This is totally true. So here we have sodium, we have our metal, and chlorine, we have our non-metal. So how does each element become stable? Well, the idea is sodium has 1 extra electron. It could lose this electron and become more stable, going back to a full energy level. Chlorine has 7 electrons. It could gain 1 electron and become stable, giving it a full octet. So I can show you this on this slide. The idea is an electron is transferred. Very key word here. That's basically what defines an ionic bond. The electrons are transferred. The metals will give their electrons to nonmetals. That means the metal becomes a cation. The nonmetal becomes an anion, and they are electrostatically attracted. Right? You've heard the term opposites attract. That's the idea here. The positive sodium metal and the negative chlorine metal. This should have the extra electron here, I guess. They are electrostatically attracted. So let me show you one. Oops, sorry. This slide just kind of shows you the picture, but let me show you one. So this question says, draw an electron dot diagram for magnesium and bromine. Okay, so first things first, magnesium is in group 2, bromine is in group 17. So I'm going to draw my two molecules here. Magnesium is in group 2, which means it has 2 valence electrons. Chlorine is in group 7, or sorry, bromine is in group 17, which means it has 7 valence electrons. So here we go. Now think about this compound. Think about this like a puzzle. I'm trying to make these 2 electrons get removed. I'm trying to remove these electrons and give them to bromine. The problem is, though, bromine can only take 1. Magnesium has 2 to give. So my formula for this compound is MgBr2. And the way that my ionic structure would work is I have magnesium 2 plus, and here I have my bromine with its full octet surrounding my magnesium. So there we go. There is my ionic formula, or my electron dot diagram for the ionic formula. This formula is MgBr2. All right, cool. So what I recommend is for next day, maybe you guys can try these. Like lithium is in group 1. Fluorine is in group 17. That's a pretty easy one. Potassium, well, I'll let you guys do this one on your own. So yeah, maybe you guys can try these and we'll go through the answers next class. Let me just look at the chat here. Mohammed in the chat says, Mr. Can we say that the elements from the same group can't related together? And I think what you mean is can't react together. And the answer for that is yes. Elements from the same group are typically not going to react with each other. It's usually between a metal and a non-metal. All right, so I'm going to hit stop recording. If anybody has any questions, let me know. Other than that, you guys are done for today. Have a good day, everybody.